All right, we're going to start chapter 10 today, which is circles. Circles is the last chapter. We're going to fly through this chapter because it's not real exciting. And I want to get to area and volume because that's when all the fun stuff begins. The way I have the schedule worked out is we will take the chapter test right before spring break. So you'll be good to go. You get a nice clean break at spring break and go away and relax and don't have to worry about some geometry looming over your head. Okay. So, terms associated with circles. What is a center, Sarah?
The center of a circle?
You got it. What is it?
Oh, is it a point equidistant from the circumference?
Circumference, what does that mean? I've never heard that word before.
From the outer edge of the circle.
A point that's equidistant from the outer edge of a circle. Is that okay?
Yeah.
Is there an inner edge of the circle?
I don't know.
Well, because if there's an outer edge, that would imply that there's an inner edge. And how are you defining edge of a circle?
I'm not sure.
I mean, we can go with that. I'm fine with it. Point that's equidistant from the outer edge of a circle. Any objections? Carter, do you have an objection? You want to jump on that bandwagon? Outstanding. Okay, that works for me. Got that? Or you want to repeat it? Repeat it, please.
I don't know. What did I say? I don't know the exact words. Point equidistant from the outer edge of a circle.
So you did know, you just lied to me. What's a radius, Patricia?
It's half of the outer edge of the circle. Half of the diameter.
Wait, diameter. I don't know what that word means.
It's the distance across the circle halfway.
The distance across the circle halfway. How are you defining going across the circle?
Top to bottom.
What if I go left to right?
Sure.
What if I go northwest to southeast?
Sure.
You're just saying that to make me happy, aren't you?
Yeah.
That ain't gonna work. Need a better definition.
Well, if you cut the circle in half, then the middle of it. Does it make sense?
No.
I can't define without the term diameter.
Sure you can. Come here. As you can see clearly, there's a circle. Draw me a radius. Change colors. Now draw just a radius. Good. What is that? Thank you. You can sit down. What is that?
Would it be? I don't know.
What kind of thing is it?
It's a line.
It is?
It's a segment.
It's a segment. Okay.
And it's half of the distance across.
You're fixating too much on the distance. Tell me what that blue thing is. I don't care how long it is. I don't care how it relates to other things. I just want to know what's that blue thing.
It's a segment.
Good. And what makes that segment special? What makes that segment a radius? This is a segment. That's not a radius, though. This is a segment. That's not a radius.
It goes from the center of the circle to the outer edge.
The outer. We want to bring up that outer edge. See what you started. How are we
Let's just go with edge. We decided.
just edge?
Yeah.
Just edge.
You've overruled Sarah and you're just going to eliminate the word outer. So you're
Yeah.
just saying edge. Okay, so if we want to use the term edge, Mr. Smarty Pants, then you need to define edge. and not the guitarist from U2.
What?
Never mind. You got that right, thank you, okay, good.
Wait, but why did you get that, Rich?
He literally said what it was.
So what's the edge of a circle?
The guitarist from U2. Wow. He said guitar from U2. Wow.
Carter?
The radius is a line segment from the center.
Wait, hold on, what question are you answering here?
What a radius is.
Okay, then you gotta wait a second.
I don't like to use edge. Just say,
Oh,
it's just
hold
a
on.
circle.
Here we
It doesn't
go.
have edges. Yeah, it's just the circle. So
It doesn't have edges,
any point on the circle.
but she used outer edge. And they overruled outer edge to just turn to
We know
edge.
what it-
Now you're telling me a circle doesn't have edges?
No.
I'm with Carter.
Uh-oh.
Wow.
You're with Carter? Oh, now we're gonna split the group. Okay,
Oh.
this'll be fun. How many people wanna jump in Carter's camp because circles have no edges? Raise your hand. And you must vote, by the way.
You must vote.
You must vote. And how many people are okay with the edge of a circle?
I don't believe in it.
Interesting.
It's unconstitutional.
Alright, Carter, present your argument. Why do circles not have edges?
Well, I just don't like the way they're using it. I don't know if they do or they don't. I just don't like the way they're using it. Like, you're saying a line segment from the center to the edge of the circle. I think it should just be a line segment from the center of a circle to any point on the circle.
Interesting.
It's just the circle. It's not-
Zach, you've been represented for the other camp. What's an edge? And how does it apply to a radius?
Is the so there's the outer marking of the circle and there's like the inside, is that considered the circle?
No,
So like if
circle's like a hula hoop.
Oh,
now,
This is not part of a
you're
circle.
right.
so then he would be right then because
I was thinking it was like a sphere
Yeah.
colored in circle.
Is that where you were with?
What?
Huh? When you were telling us the definition of the center, were you assuming that the inside part is also part of the circle?
Yes.
Only the red part
Okay.
is a circle.
I should have said that.
So are you okay? Do you want to join Carter's camp now?
Sure.
All right, Edge people, the leader of the Edge group is going over to the other camp. Are you with her, or are you going to fight for what an edge is?
I'm with
I
it.
think it's a good thing.
You think it's a good thing?
we're
All right,
on
excellent.
championship.
Carter, we're back to you then. Since we're eliminating the edge, we need to go back to the center. What's a center then?
A point inside a circle that is equidistant to any point on the circle.
Equidistant to any point on a circle?
Any point on the circle.
Okay. So then what's a radius?
A line segment from the center to any point on the circle.
Okay. Patricia, are you okay with that for a radius?
Yeah.
Okay.
Wait, can you?
What you were fixating on is the distance too much, and we'll talk about the distance later. We don't really care about that. Question?
Carter, can you repeat that?
Which one?
The radius ones.
A line segment from the center of a circle to any point on the circle.
So what's a chord? Wilma?
Isn't it a line segment from one edge to the,
Oh, wait, I thought we said we're eliminating edge.
from one point of, on the circle to another point that does not go through the center?
It's a chore.
Say that again.
A line segment that starts on one point on the circle and connects to another one not going through the center.
You can't pass through the center.
No.
That's a chord. Okay, what about this? You want to argue then that that is not a chord. Okay, how do we feel? You like it? What do you want?
I think it is a chord.
I'm sorry, what?
I think it is a chord.
A what?
Or a chord or
A
whatever.
chord, yeah, okay.
Is it really?
So you're arguing that this is a chord?
Oh no, it's a chord. It is.
Can't
Yeah.
quite tell.
How do you feel about the rest of her definition?
It's good except for the last.
So you, okay,
I like it.
all right, split camps again. How many think Wilma's correct in that this is not a chord?
I have no idea,
How many think that Kelly's correct that this is a chord? Interesting.
No, I was,
Well, you voted twice.
I was like,
Welcome to Chicago. Next thing you know, dead people are going to be voting. We'll pick up where I like the first part of the definition. The second part we still need to talk a little bit more about, so we'll get to that in a second after we look at what's a diameter. Nick?
Oh, it is a line segment that runs from one part of the circle through the center to the other side of the circle.
Can you phrase that a little more eloquently?
A line segment that runs through the circle through the center.
A line segment that runs through the circle through the
whole
center.
circle.
Not bad.
Whole circle.
Is that a diameter?
No.
That's what you said. You said a line segment that runs through the circle through the center.
It starts at the circle, runs through the center, and ends at the circle.
Starts at the circle, runs through the center, ends at the circle.
Yes.
And again, is there a more eloquent way to phrase that?
I'm not sure. Probably.
Let's go back to the shell answer man for today. Carter, what do you got?
A line segment from one point on a circle to another that passes through the center.
In essence, that's what you said. That's just a little cleaner.
You just flipped the second and third phrase.
I understand. Okay, so now we come back to the discussion. Wilma, so you're arguing that a diameter and a chord cannot be the same thing? That they are separate entities? Awesome. Kelly, your argument?
Well, it's
Are you going with the golden retriever argument?
Yeah.
Okay. So all diameters are chords, but not all chords are diameters?
Yeah.
Okay. Everybody take 30 seconds to process that, then we're gonna vote, and this will be the deciding factor on how we define them.
Why did I just look it up?
Is there a right answer?
Of
No,
course there's a right answer. What?
no, it's just however you wanna define it.
No, for what a chord is. Can it be, is there a right answer to a chord?
The right answer is whatever you guys wanna define it as. So we can proceed with either one. If we decide that we wanna make the chord not a diameter, that's okay. Or if we decide we wanna make all diameters chords, we can progress with that also. Okay? All right, ready? How many people wanna side with Wilma and make chords and diameters separate things? Raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15. That's enough. We win. Okay. So for our purposes, a chord and a diameter are separate. We don't have to worry about the whole golden retriever argument.
Can we define it again?
What?
Chord.
Chord? Yeah, it's a segment connecting any 2 points on a circle that does not pass through the center of the circle. Whereas a diameter is a segment connecting 2 points on a circle that does pass through the center of the circle. Rich, what's a circumference?
That is the area inside of the circle.
Nope. That would be area.
Well, then I have zero idea.
Come on. You know what a circumference is?
I know how to solve one. Do not know what it is.
You know how to solve for the distance?
I think. Now,
Okay, so
now
what
if
would
we
that
had a
distance
spot, I can't
represent?
remember. It would represent, let me think.
What do you think?
I do not know what pi represents in a circle.
Well, who cares about pi? Well, I do actually, but if I come back up to this picture that we've drawn, come here. I won't hurt you
Okay.
that much.
Okay.
Draw the circumference.
Oh God.
He has nothing to do with it.
I might need to bring him in though.
Oh, you can call it.
That would be my best lesson ever.
Phone a friend? What? No. I gotta think now. Okay, circumference. Pi times diameter.
There's a stem.
A stem?
A stem.
Oh,
from-
it does. Circum. Center. Okay.
No.
No, it's around. It is around. It's around. It's the area around a circle.
there you go, Nate. Hell no.
Excellent.
Not the area. The
Okay, good.
Distance around a circle.
The distance around a circle. Are we okay with that? You don't like that?
No, I just have a question.
Sure.
Couldn't you just call perimeter too?
No. Great question though. Why can't a circumference, it is analogous to a perimeter, but why can't a circle have a perimeter? Or why can't a hexagon have a circumference?
Because there are no sides on the circle.
Beautiful.
There's no circle on a hexagon.
Okay, here's another thing we need to make make a decision on. Do we want to consider a circle having no sides or a circle having an infinite number of sides? No sides? Okay, I'm good with that. So then what Grace says, perfect. The circle has no sides, and in fact, a circle's not a polygon. Polygons have perimeters, circles have circumference. Kelly has her hand in the air.
I was gonna say that I didn't like that definition because you could just draw another circle around it and
Wait, you started mumbling at the end there, you trailed off.
I didn't like that definition because then you could like draw another circle around that circle and that's pretty much could also apply to that.
You don't like it because this would satisfy Rich's definition? That is a circle, distance around the circle.
It is. Well, let's think about this.
Show.
Let us discuss. I like that. The distance,
Don't say
it's better than what I got. So I'm going to go with the big circle doesn't work, but my definition was worded wrong. Yeah, so I don't know how to word it.
Took a true man to admit his shortcomings. Good, now fix it.
Okay.
So how are we gonna define this?
It is the distance.
I'm sorry, what?
A distance. Oh, distance of a circle.
Distance of a circle.
That doesn't sound right.
No, doesn't.
That doesn't work. A distance around and on a circle.
Around and on a circle.
The distance of the circle.
Around and along.
That work?
I don't
Around and
know.
along?
Wait, let's,
I guess.
you know how we solve this problem. Let's go to the person that caused the issue. Kelly,
Let's do it.
what's the circumference?
She don't know.
Let me figure out what it is. I just don't have it. She got wrong. It's the distance.
It's hard.
That's harder.
I kind of like the distance of a circle. I like that one.
So just change around to of, and you're happy? Is everybody else happy if we just change the word around to of?
No.
Why not?
Oh, Carter, I saw your hand in the air.
That sounds wrong, but the distance from a point on the circle to that same point going around the circle.
I like that
Or
one.
going
Clockwise or
traveling on the
Going in a
circle.
I like that one.
That's too complicated.
Why is it too complicated?
Could be.
No, because it could be.
It's not horrible.
It makes complete total sense.
All right, great. I like it. Let's go with it.
Alright, so what is it?
I don't know. He's talking.
What is it?
Ask him.
Carter.
Google's
I get it.
Distance
Uh-huh.
from a point on a circle to that same point with the line like on the circle.
How about we start with the non-zero distance?
Non-zero.
Yeah, because that'll eliminate going from the point to the point with not covering any distance. The non-zero distance from a point on a circle to that same point.
Points. Yeah. I don't know what to say. What did I say the first time?
I don't know. I wasn't
Points of
listening.
circle.
Distance from a point to distance from a point on a circle to the same point on the circle going around. Non-zero. Yeah, he says.
So now we need to talk about pi. Yeah. Pi. Looks like that. Where's it come from? And don't say Baker Square. Yes, Zach?
I know, we talked about this last year, it's a relationship between, like the circumference and the area, or
Close.
something like that.
The relationship between the diameter and the circumference.
Good. What's special about it?
It's never ending.
It's never ending. And?
There's no pattern.
And there's no pattern. Never repeats, never ends. The definition is the circumference of a circle divided by the diameter. So you draw a circle, you measure the distance around the circle, then you measure the distance across the circle, divide those two, and you magically get this number pi. 3.1415, blah, 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 blah. We are, Wilma.
Wait, so is the relationship between the circumference and diameter?
Yeah, it's circumference divided by diameter.
That's a circle.
No matter how big the circle is, no matter how small the circle is, if you take the circumference and divide it by the diameter, you will always get this magic number pi. Nate?
How did the people who invented pi figure out the circumference without using pi?
They literally measured it. Like drew a circle in the sand and then took a ruler or a piece of string and laid it out into a circle and then laid that out and
How do you
measured
know-
its distance.
How'd they know it was a perfect circle?
Well, they didn't. They probably used a compass of some sort to draw it. And not on paper because they worked in sand.
What about papyrus?
Yeah, but papyrus was a hot little item. You didn't waste papyrus just for some circle experiments. It's like on the computer. You do all the work on the computer, but you only print really when you got the final product.
Yeah.
Similar thing. You did all your work in sand and you didn't put it on papyrus until you were sure your answer was correct. Okay. Regardless of what your worksheets, quizzes, or tests say, even if it says use 3.14, we are always going to use the pi button on your calculator. That will give you exactly pi. 3.14 is an approximation. We also want to talk about what makes an exact answer exact and an approximate answer approximate when we talk about this. So circumference, we have a definition of the term circumference, so we know what a circumference is, but now we can find the distance. And the circumference, which is used capital letter C, is equal to 2 pi r or d pi. Because Patricia told us that the radius is half the length of the diameter is twice the radius. Either one of those formulas works. Exact answers will always have pi in it. Approximate answers, you're going to use the pi button on your calculator and multiply it out. Decimal places rounded to the tenths or hundredths. You knew this already though, right? Yeah. Well, at least Jack did. He's the only one that responded. Okay, circle has a circumference of 27 centimeters. What's the exact radius? Hey, why are you getting out your calculators? Go ahead. Just because you'll feel better about it if it's next to you. It's like your security blanket.
I love it.
Oh.
As we work through chapter 10 and then into chapters 11 and 12, you need to be aware of what it means to show work. You're going to be required to start with a blank formula on every calculation. So Nate, what formula am I using here?
Diameter pi.
You want to use d pi?
Yeah.
But then we're going to have to use that to get the radius.
Okay, 2 pi r.
Good answer, Nate. Start with a blank formula. Plug in what you know. Nate, what do you know?
The circumference. Yeah.
Is?
27.
Good. Plug in what you know. Solve for what you don't know. How do I get r by itself? Kelly? Divide by 2 pi. Can that be simplified at all?
No.
No. That's the exact answer.
I'll take that out.
But who knows? Any problems there? Hot diggity. Notice exact answer in terms of pi. But what if we want the approximate value? What do you got?
Would it be 4.3?
I don't know. Would it be 4.3?
Yeah, it would be.
4.3. Be careful to put that in parentheses. I assume you did that, right? Put the 2 pi in parentheses.
I did it separate.
Good,
Yeah.
even better. if you just type in 27 divided by 2 pi, you're going to get an incorrect answer. You're going to get an answer like 40 something or another. That has to be in parentheses, the 2 pi. Kelly,
Where is the
the pi button is above the caret.
Where's the
Second.
The caret is the raised to power button.
Right below this clear button.
Oh, I found it.
Clarification, exact answers does not mean copy all 10 digits off the calculator. That doesn't make an answer exact. What makes an answer exact is leaving it in terms of pi. Okay? Moving on. Find the circumference of the circle to the left. There's left, that's the circle we're talking about. Find the circumference. Multi-step problem here. And notice it says exact circumference.
Did we get a test?
No.
I never get a chest. It's on infinite. So
Yeah, scores are online.
I saw it.
Oh, okay.
Exact is correct, yes. Taylor, what do you got?
34, 5.
Why?
Because you do Pythagorean theorem, find the hypotenuse, which is the diameter.
Whoa, that was bad. Let me try that again. That's better. So you did Pythagorean theorem?
Yeah.
16 squared plus 30 squared equals KL squared. Anybody not use Pythagorean theorem? No, it's a triple. 8, 15, 17. Anyone? Bueller? No? Okay, well, that's fine. And what KL turn out to be?
34.
34. Then what?
Could have been one of the things.
Which thing did you put it into?
Circumference equals diameter times pi.
34 pi
7.
centimeters. Good. Because circumference is a distance, so it would stay with the same units. Well done. Any problems? Okay, walking around, I saw some of you take the 34, then divide it in half to find the radius of 17, and then plug it into circumference equals 2 pi r. That's okay too. You get back to this 34 pi because you knew the diameter. Either one. And again, make sure you identify that as a right triangle before you start plugging and chugging into Pythagorean theorem.
How would we solve it if it wasn't an degree?
Oh, this particular problem?
We were, yeah.
To answer that question, I have to put you off for a couple days. Because I know stuff that you don't know. So the answer right now would be you don't. Okay, you say, I don't know how to do that, you move on. 4 pi. What makes two circles congruent, Maddie?
They have the same circumference.
Awesome. Is that okay? Two circles are congruent if they...
No, I just have a question. Couldn't doesn't just have one thing need to be congruent, like the radius? If the radius is congruent,
Well, she said circumference, that's one thing.
would they both be congruent if either of them were congruent?
You think about your own answer. I'll get back to you in a second. Yes, sir.
Well, I think Alex right, he just can't say it in words. If.
Well, what's he gonna do? Use flags and semaphore?
Well, he's not really saying. Yes. The radius needs to be congruent to the radius of the other circle.
radius of one needs to be congruent to the other, and or.
Do you have any idea what he's saying?
I know, but you can.
You don't, so what you're saying is Maddie's wrong?
No, I'm saying that he's right. It can be more than.
It could be more than
It doesn't
that.
need to be the circumference, even though it will be. But if you have both radii,
Very good, radii, very good. R-A-D-I-I.
then they are also congruent.
Mhm.
Yeah. So it is the circumference, but it can also be the other measures.
So do you want to add to her definition?
Yeah.
Or are you saying her definition's wrong,
Adding.
or you're adding to it?
Yeah.
So what would your new definition be?
The radius is our congruent.
Radii.
And or the diameters are congruent. And or their circumferences.
Do we see a lot of definitions with and or in it?
No.
Right.
Well,
Hold on, Carter.
Congruent circles are circles that share any same measurements besides a chord.
Any same measurements. What can you measure?
The same, the radius, diameter, circumference,
And nothing else?
the area.
Nothing else? Back to my original question, is there anything wrong with Maddie's definition?
no.
No, can we go with that?
Yeah.
Okay, good. Circles that have the same circumference. Notice, however, this circle is big and fat and that one's skinny. Does that matter?
But, you know.
Yeah, there's no such thing. Okay. All of our circles have an infinitely thin thickness because remember it's made up of dots or points, and points have no thickness. That's just different ways of representing it. That's not actually a circle. Just trying to make things more complicated. What are concentric circles, Tyler?
I have no idea.
Let's break the word down.
Um,
What's con mean?
Together.
Together. What's centric mean?
Center.
Good. So what are concentric circles?
Circles that share the same center.
Perfect. Like a bullseye. Circles that have the same center or common center. Tyler, are congruent, well, hold on, let me start over. Can congruent circles be concentric?
They have to be like layered on top of each other. Oh, I guess they don't. Well, they might. I'm not sure.
Let's do the easier one. Can concentric circles be congruent?
Only if they're layered on top of each other.
And how many dimensions does a circle have?
Two.
Two. They are?
X and Y.
Yeah, x and y, length and width. So is the concept of a circle stacking on top of each other make sense in this scenario?
No.
Okay, so let me ask my question again. I can't even talk. Can concentric circles be congruent?
No.
No. Can congruent circles be concentric?
No.
No, because they would be the same circle. Carter,
What if like you have two circles that are congruent and they're concentric, but I'm thinking like 3D, but it's not 3D, so it's like two circles, but it's almost like they're crossing. Do you know what I mean?
no.
Like forming like an X almost.
Oh, I know what
It's
you're
like
talking
one's
about.
going this way, they're perpendicular
Like a different
circles.
perpendicular circles
What?
in like a 3D dimension.
Yeah, but they still be 2D because they're just circles. Like they're not.
So you're taking, I see what you're doing.
Like a gyro.
Yeah. Except.
A Greek sandwich?
A euro.
Oh, that's a euro, sorry. Right. And what does that have to do with anything? So you want to take the circles into 3 dimensions?
Except it's not 3 dimensions. It's just.
It-
It's.
That's intense.
It's just a circle, except you're just looking at it. It's just a circle.
It's just a circle.
Well, it's not.
So you, in other words, you're arguing with Tyler that his answers are incorrect.
Yeah,
Okay. Given the fact that we go into 3 dimensions.
I don't think it's 3 dimensions.
You don't think it's 3 dimensions?
It's not 3 dimensions.
Wilma?
Wouldn't it be a three-dimensional space but a two-dimensional circle?
Ooh, yeah. We're going.
So you're saying you can have a 2-dimensional circle in a 3-dimensional space?
Yes.
Can you have a three-dimensional circle in a two-dimensional space?
No.
Circle.
I just threw that in there just to confuse people. No, what's your name? That's Carter. Who are you? You're Tyler. Tyler. What's he talking about? Do you have any idea? No, me neither. Okay. You are correct. If you expand it into 3 dimensions, you could have 2 circles that are, let's say, perpendicular to each other. They would look something like a globe, for instance. If you took a globe and you look at the lines of latitude, you would have one circle like this, and then the other one kind of does like one of these guys,
Yeah.
and they share a common circle. Yes, that would be fine, but we're talking purely about 2-dimensional.
Are those 2-dimensional though? Because it's not like an actual.
No, it's still 3-dimensional. As soon as anything comes up off the board, it becomes 3-dimensional. So we can argue about that when we get into the next chapter or the following chapter when we start talking about volume, and then 3-dimensional becomes fair game, but all of this stuff is 2-dimensional. So being 2-dimensional, the idea of stacking things on top of each other doesn't work. So if 2 circles are concentric, you take a circle like this, and then you take a congruent circle that's concentric, it's going to lie right on top of it. Well, lying on top makes no sense. It's got to be the same circle. So therefore, you don't have concentric circles. You have but one circle. Grace?
So concentric circles can't be congruent, but could they be similar? Would the circles be similar?
Ooh, that presents an interesting question. What makes 2 circles similar? Go ahead, Grace, you started.
If you can create a proportion with their either radius or radii,
Radii,
and
good.
their diameters or circumferences.
So are circles similar? Can circles be similar?
Yes.
Are circles similar?
Not all.
Emma? They being similar circles? No. Go ahead, back to you.
Well, if it's perfect circle, then they can.
Well, okay, hold on. All of our circles by definition are perfect. As soon as they're not perfect, they're a little, distorted, it's no longer a circle for our purposes.
So then they can be similar because they'd have the same structure. Because with other shapes, they what makes them a lot of times similar or not similar is that they have different length sides. But circles, you can always proportion with it.
Nate?
Aren't all circles always similar?
Hold on. Grace, what do you think about that?
Yeah, I think so.
Yeah, they are. So similar, before we get into this example, all circles are similar to each other. A circle is a circle. It's just different sizes. And by definition, the way we define similarity is same shape, different size, and therefore all circles would be similar. Not concentric circles, these are called overlapping circles, and pretty much reduces into a segment problem with a couple circles attached to it. So notice that the diameter of circle X is 22. What segment in that picture is represented by 22 meters? Michael. XZ. I'm sorry, what?
That isn't the diameter.
It isn't? What is it?
That's the radius.
Oh, so how long is XZ?
11.
11. All right. Where's the 16? Go ahead.
Half of WY. It would be 8.
WY is 8. This is 5. How long is this? 3. And how long is this? 6. So again, the only thing with the circles the only thing that the circles are doing for us in this picture is giving us 2 of the distances on the segment. Then the rest is just by using subtraction there. Then we can complicate things later by putting a point here and then maybe drawing some triangles and finding all kinds of fun stuff. What shape is this?
Kite.
How do you know it's a kite? Go ahead.
The bottom of the segment, the lines are longer than the top.
So this is a kite just because this is longer than that? A little bit of quadrilateral review here. What makes a kite a kite? What the bear sheet gonna ring? the bell she gonna ring. Two pairs of congruent sides, non-opposite sides. That makes it a kite. I think we're done. That was exhausting. Have we seen this one yet?
No.
Oh, it's a good one.
That squirrel has a bite on it.
Squirrel bit him right in the face.
That squirrel is scared nuts.
Day one, Simon Sheets up there is a new folder on Schoology.
That's a honey.
You are good to go. Yes,
I
sir.
lost all the
Do you want to say it again?
Yeah, play it again.
And then,
again.
do we have,
Maybe,
do
Go
we
ahead,
want to be
Jack.
in radian or degrees?
Always in degrees in this class.
Oh, yeah,
I wonder
they're
what
coming
it
back.
took that I didn't like.
What?
Oh, God.
Back.